Hi everyone, welcome you all to EITRA. Today in this video we will design and simulate a basic design of PV power generation system for home use. We will use MATLAB Simulink to do the whole design and simulation work. But before going to Simulink, let's first understand the basic working process of solar home system. Here's our solar PV array. We know that solar PV array use sun, irradiation and temperature as input to generate DC power as output. This power will be used in home for different appliances, but we know we use single phase AC supply in our home ranging from 215 to 240 volt. So to convert DC to AC, we need to use a power electronic device inverter, but this inverter only produces pulsating AC, not pure AC. So to get pure AC, we need to use a passive filter like LC or LCL filter. Moreover, solar power from PV array is not constant throughout the daytime. During afternoon, we get maximum power, but during morning or evening time we are not getting as much power as the peak power. But our solar home needs a constant supply of 240 volt AC, but solar power varies its power throughout the day. So to get the constant voltage of 240, we need to use a boost converter which will maintain a constant voltage level throughout the process. So now let's move on to Simulink. Here we have already taken a Simulink file, blank file. Now we need to design the solar system as far as we have presented in the PPTX. So first we need to take PV array. Now as you can see here in PV array we have two ports of IR and T. That's the input of PV of irradiance and temperature. We can give that using constant block. So first this constant block we are giving irradiance. Let's take something around 1500, and let's take another constant block to give temperature, and we'll use a reference temperature of 25 degrees centigrade. Now let's connect this to with this block. We'll use a series RLC branch as capacitor parallel to the solar PV array. We'll use this capacitor parallel to the solar PV to minimize the voltage ripple from solar PV. Now let's design the boost controller. Here we have taken another block of capacitance parallel with the solar PV array. We are taking this block to minimize the voltage ripple from solar PV. Now let's design the boost converter. As we know, boost converter is consist of inductor, diode and switch. Let's take those blocks first. Here you can see we have taken an inductor, a diode and IGBT as switch. We also use another capacitor in parallel with this converter circuit, boost converter circuit, to minimize the voltage ripple from the boost output. Now let's join these blocks first. So we have completed the designing of boost converter. Now let's design the inverter circuit. We'll design the inverter circuit using universal bridge. Let's invert it. Here you can see we have a plus and minus sign of DC side and ABC of three-phase AC side, but we are using a single phase AC supply, so we will change the number of bridge arms to 2 and power electronics devices IGBT diodes. We need to add a load side also. So for load we are using nothing but a series RLC branch and changes it to R load and apply it. Now let's connect these two blocks first. Here we need to see the output, so we need to use voltage measurement and scope to see the output waveform. So let's take the voltage measurement block and a scope and connect. Let's check the output of boost converter also. So just copy this two block here and connect with the boost output. We can also view the output of PV. So let's take bus selector and connect here, and inside the bus selector let's uh, delete these two signal and take VPV or voltage of PV, apply and use a scope to view the output. So we are pretty much done with the design, but here you can see in the these two IGBT switches we need to provide gate signals to run these two blocks. So for IGBT switch here in boost converter we'll use a pulse generator, and here inside this pulse generator we are taking amplitude of 1 and period of 1 by 1500, and pulse width modulation we are taking 50%. So 50% of the pulse width modulation will be used. Let's connect this block to this ground, and for the universal bridge let's use a PWM generator with 2 level, and inside of it let's take internal generation of reference signal of modulated signal 0.8. Okay, and connect these two things. So we have completed the design process, but to run this design we need to use a power GUI block which will run the whole simulation. So we have placed it here, and here in the stop time we do not need to run the simulation for 10 seconds. Let's run this for 2 seconds only and simulate the design. So after running the simulation we can now see from VPV block, we can see that there is a 120 volt or something close to like that voltage generated from solar PV, and it's the solar PV voltage. Now let's check the boost voltage. So here in the boost voltage range you can see that we are getting something around 240 volt of boost voltage, and the output voltage in the load side you can see the 240 volt AC voltage. Let's zoom it a little bit. But the problem here you can see that this is not pure AC, which we have stated earlier that by using only inverter circuit we can only change the DC voltage to pulsating AC voltage, not pure AC voltage. So to change the pure AC voltage we need to use passive filter, something like LC or LCL filter. So now let's add LCL filter at the output of the universal bridge. So here we have installed a LC filter by this is the L and this is the C at the output of the universal bridge. Now let's again run the simulation and see what are the changes happens. So the simulation is done. Let's check the output. The output scope. As you can see, we are getting pretty much good out. You can see we are getting pure pulsating AC. So we have converted this DC voltage into pure AC output. So according to this block diagram, we have designed that same circuit in the Simulink library, and we can see that in the Simulink we had successfully generated AC voltage from solar PV. From that basic design, we have customized this design. We have generated 2 kilowatt 145 volt PV array, and the output of this PV array is 240 volt after boost conversion, boost converter and inverter. And so we are giving 240 volt of output voltage. So from that basic design we have customized this Simulink design. Here we have designed for 2 kilowatt and 145 volt PV array. After boosting this, that voltage will be 230 volt, and that will be given as a pure sinusoidal voltage to AC load using this LC filter. You can get this file from projectitsbd.com. Here's are the websites. Not only this project file but also other electrical components you can buy from here. So that's the total video for today. If you have any questions and if you need any other MATLAB projects, you can contact us to this channel and Project Its PD. The link will be given in the description. And if you have any other question regarding this design or any other query, you can just comment in the comment section. Thank you.